Welcome to my Physics Lab 3 on black holes and orbits. There are two parts to this lab, both done using GlowScript models. The first part of the lab was to determine the mass of a black hole based on the force it has on an orbiting star. The second part was to create a scenario where a moon orbits a planet and a spaceship is affected by the gravity from both of these entities in an orbit. The purpose of this lab is to explore Newton's second law as objects are affected by gravity when traveling through space. Here is a preview of the results from each part of the lab. In the first part of the lab, the system is the star and the surroundings is a black hole, while in the second part, the spaceship is the system and the surroundings are both the star and the moon. A key formula used in this lab was the velocity update formula, which is derived from Newton's second law. Another key formula for this lab is the position update formula. Some other physics principles used in this lab include the universal force of gravity formula and a good understanding of how to find the change in a vector. For this lab, it was also important to understand circular motion, including Fnet perpendicular and how this is added with Fnet parallel to find Fnet. Now I will go over the GlowScript code for each of the two parts of this lab. First, I will go through part 1, where the initial conditions include the mass of the star and delta t being the amount of seconds in one day. Now, I will go through the calculation loop, which uses many formulas, the first of which being momentum equals mass times velocity. Then, it finds the change in both the velocity and momentum. After this, dp dt and thus Fnet is found. The formula for dp dt parallel is also used and then subtracted from dp dt to find dp dt perpendicular. Finally, the mass of the black hole is determined using algebra on the formula for Fnet perpendicular. All the forces are then shown as arrows in the model. Here is the results from the code and the average mass found for the black hole. Now, I will go through part 2 with the initial conditions specifying the mass of the planet, moon, and ship. The code is set to end after 1 month, which is T max in seconds. Most importantly, the initial ship speed is included at the bottom of the screen. In the calculation loop, the forces acting on the moon and ship are defined using the universal gravity formula, and the net force acting on these is used in the velocity update formula. The velocity found from this formula is then used in the position update formula to accurately move the ship and the moon according to gravity from each entity within the entire scenario. Here are the results from this code. The purple path is the ship and the circular blue path is the moon. At this point right here, you can see how the moon's gravity also affects the orbit of the ship. While there was no data collecting or actual experiments to do in this lab, there is still room for potential errors in the code that I may have missed. Also, the ship did not make a figure-8 path between the moon and planet in part 2, which may have been possible with more trial and error on the initial velocity. According to Newton's second law, Fnet and the change in momentum are actually equal to each other. However, they do differ in the formulas used to derive them, with the Fnet formula seen here and the dp/dp formula found in the change in momentum. In a system with a black hole, star, planet, and moon, the same process would be done as in part 2 of this lab, but this time with many more forces being applied as each entity would interact with each other. These interactions would not be equal, and their strength would be determined by the mass and distance between each entity. Thank you for listening to my lab on black holes and orbits.